Welcome back, guys. So this is question 2.20 of our book of Nilsson, and the title of the book is Electric Circuits. So the statement of the question is the current Ix in the circuit shown in figure P2.20, this is the figure, okay, is 50 milliamps. So let me write here the given data. So the current, which is I of x here, this is what? This is 50 milliamps. Okay, which is what? Which is 0.05 amperes. Okay, so this is what which is given here, and also the voltage V of x is 3.5 volts. So this is V of x and the value given for it is 3.5 volts. So V of x is how much? That is 3.5 volts. So on the basis of it, we have to find I1, which is here, V1, which is here, this one, VG, which is the source voltage, and the power supplied by the source. Okay, so this is the source, the power supplied by it. Okay, so in order to solve it, we have to keep one thing in our mind, that if we have any component, either a passive component or an active component, there are three quantities associated with it. So what are those three quantities? Those are V, I, and R, okay, which are voltage, current, and resistor for the linear element. Okay, so if any two of them are given, we can find out the third one very easily. Okay, so let us solve our question, and in solving it, let us first proceed with this one, and we can see that I1 is the current which flows through 200 ohm and 175 ohm as well, because these two are in series with each other. So therefore the voltage value is known, which is across it, and the resistor is also known. So we can very easily find out the value of current because the voltage and resistors are known. So we can find out the value of I1. So from it, the part 1, which is I1, that is what? That is V divided by R by the Ohm's law, which is V equal to IR. Okay, so let me put the values here. The value of V, that is V of x, that is known, and that is 3.5 divided by R, which is how much? That is 175. Okay, so let me solve it, and after solving it, the value for it is 20 milliamps, and that is the solution of part A of my question. In part B, we need to find out the value for V1. Okay, V1 is unknown, and here we can see that if we can see this node, the current Ix is coming here and then splitting into two components, where this one is I1 and let me call this one as I2. So therefore applying KCL here, we can very easily see that I of x, which is the current coming towards this node, is equal to the I1 plus I2. Okay, or from it, the value of I2, which is flowing through this branch, through this 250 ohm resistor, that is I2 is equal to Ix minus I1. Okay, so the value of Ix is known, that is 50 milliamps, and the value of I1 is also known. So let me put them here. The value of Ix is 50 milliamps and the value of I1 is 20 milliamps. Okay, from it I can get 30 milliamps. After finding out this I2, we can see that here this is the resistor across which we have to find out the value of V1. The value of current is known, which is 30 milliamps, and the value of resistance is 250. So let me find out the value of V1, that is 250 multiplied by I2. Okay, so that would be 250 multiplied by 30 multiplied by 10 to the power minus 3 due to this one. So solving it, we will get 7.5 volts. So that is what? 7.5 volts is the value of the voltage across this 250 ohm. So we have found it out, and that is the solution of part B. In part C, we have to find out the value of V of G, and here in this loop, let us use the what? Let us use here the KVL, and applying KVL here, I can very easily see that the value of Vg is equal to what? That is equal to the value across this 50 ohm resistor. So in this loop, we can see that this is V50, and V50 is the voltage drop across this 50 ohm resistor plus this V1. Okay, so plus this V1. Do we know the value of V50? No, we don't know it, but we know the value of the resistor. We know the value of the current which is given. So we can very easily find out the value of V50, that is Ix multiplied by 50 ohm. So let me put these values, that is 50 multiplied by 50 multiplied by 10 to the power minus 3. Okay, so this would be 2.5 volts. Okay, so the voltage here is given. Let me write these voltages here. So V50 is 2.5 volts. The value of V1 is 7.5 volts. So adding them together, I will get 10 volts. Okay, so that is what? That is the solution of part C. In part D, I have to find the power supplied by the voltage source. So in order to find the power supplied by the voltage source, let me solve it here. That is the power supplied by this Vg, that would be Vg multiplied by the current which is going through it, and that is I of x. Okay, so the value of Vg is known. The value of Vg is 10, and the value of I of x is 50 milliamps, so 10 to the power minus 3. So ultimately we will get what? It will be 0.5 watts, what we have found out. Okay, so that is basically the solution of question 2.20. If you have any question, you can ask me in the comment box. See you soon.